In this video we're going to look at how to plot a standard curve and then how to use that standard curve to determine the unknown concentration of a sample. Now in this example we're using data from a spectrophotometer, but you could use data from any piece of equipment that can generate different readings for a known concentration. So here we've been provided with a set of data. We've got the absorbance at 590 nanometers, and what we need to do is plot this data and determine the concentration of a sample with an absorbance of 0.6. So we have our graph paper, and the first thing we need to draw is the two axes. Now we want to make the best use possible of the graph paper, so we need to make sure that we fill the extent of it. Now looking at the data, the concentration, which is in millimolar, goes from 0 to 12, and looking along the bottom of this graph you can see that we can easily get in those 12 digits, 0 through to 12. So along the bottom of the graph we're going to put the concentration in millimolar. Don't forget to label your axes millimolar. Now you always put the thing you know, which in this case is concentration, along the bottom of the graph. The thing you're trying to measure, which in this case is absorbance, you put up the side. Now absorbance is running from 0 to 0.98, so roughly 0 to 1. Looking up the side of the graph, this is great because we can use a scale from 0 up to 1. And again, don't forget to label the axes. In this case it's absorbance, and traditionally we always put the wavelength used, which in this case is 590 nanometers, in brackets after the absorbance. The next thing we need to do is plot the data. Now when you're plotting data, make sure you're using a sharp pencil and make sure that you get the points in the right places. So double check that points are going in at the right places. So my first point at 1 millimolar, the value is 0.09, so make sure you get the point in, and continue to do that until you've plotted all your points up the graph. And then finally we put in the last point of 12 millimolar and an absorbance reading of 0.98. Now we've got the points plotted. We know that these points should fall on a straight line because of the Beer-Lambert law, because here we are using spectrophotometry. However, if you look at these points you'll see they're not quite on a straight line. There's a little bit of a wavering going around. Therefore we need to fit a straight line. And to do that we look carefully at the points, and then we draw in a line that distributes the points equally around that line, and that will give us the line of best fit. It is also key that we don't go beyond the highest or below the lowest readings. So we don't go above the 12 millimolar reading with our line. We cannot extrapolate the data. So don't draw beyond those points. Finally, we need to give the graph a title. And in this case it's a graph of absorbance against concentration in millimolar. And we always put the item that is on the vertical axis first and then against what is on the horizontal axis. Now that we've got the graph plotted, we want to work out the unknown concentration of our sample. We know that the sample has got an absorbance of 0.6. Therefore we draw a line across the graph from 0.6 on the absorbance axis until it gets to the line of best fit. When it intercepts that line of best fit, we then drop a line down to the concentration axis. And when we do that, we can read off that the concentration of our sample with an absorbance of 0.6 is 7.4. So the correct answer is 7.4 millimolar. And that is it. That is how you plot a standard curve and determine the unknown concentration of a sample.